Okay, we can go ahead and get started. Thank you, everyone. My name is Jessie. I am the Director of Technology here at EPIC, and I am thrilled to be joined today by my collaborators at SimpleLab and the Internet of Water Coalition to introduce you all to some work that we've been doing over the last 6 months or so to understand who provides our drinking water. I will let each of them introduce themselves throughout the course of the presentation, and just logistics-wise, please don't hesitate to ask questions throughout the webinar. We will be trying our best to answer them as we go, but know that our goal is to spend roughly half of the time discussion. And even that is probably going to feel short and unsatisfactory because there is a lot of material to cover. So we hope this is just the first of many conversations that we're able to have. And we will have a short form at the end for any additional input or questions that you'd like to have answered. So without further ado, I think we can hop into it. Yeah, so for starters, I just wanted to share a bit more about EPIC and how we arrived at this question. We at EPIC are really focused on how do we speed up environmental progress? And for our technology program, that really means how do we, one, equip folks within environmental agencies to leverage innovation for decision-making, as well as how do we address some of the policy and regulatory barriers that inhibit us from doing so? But sometimes we find ourselves confronting really critical data gaps that, if addressed, would dramatically speed up environmental progress. And the project that we're going to talk about today is exactly an example of that. When I started at EPIC, I was really focused on how do we improve public trust in tap water and how do we make it as easy as possible for folks to know if their water is safe to drink or not. And a first step in that process is just knowing who do you get your water from, which was not always easy to tell, and especially not so for renters. In parallel, I had other colleagues at EPIC that were really looking at which communities are benefiting or receiving state revolving funds to improve water infrastructure. And understanding and characterizing those communities was really hard to do for the majority of the US, where we do not have these water utility service area boundaries. And I think the last thing that helped us arrive at this question was the Justice 40 initiative. And component of that is clean water infrastructure. There's nothing right now in the climate and economic justice screening tool, which will be used for screening and directing federal funding for drinking water. And in large part because we are missing this really critical data gap, or this critical data that shows which specific communities lack access to safe, affordable, and reliable drinking water. And so those are just some of our motivations for coming into this work. Recognizing how many folks are on this webinar and the plethora that I do not recognize, there are probably many other motivations for why this would be useful and important, and we're excited to dive into that today. Perfect. So in today's presentation, we are going to be talking about the who, the what, the why, the when, all of our process for developing this data set, and speak to how it can be maintained and improved in the long run. Again, please ask questions in the chat or in the Q&A as we go, and we will be doing our best to answer them. So to get started, service area boundaries are a unique and very complex issue. We had one person say, I've been wanting this data since 1994. And we know that it's really hard to develop. There's more than 50,000 water systems, many of whom serve less than 500 people, which just makes it really hard to collate the data. And a lot of this data was, the boundaries were drawn before we had digital maps and digital infrastructure. And so now it's this gap of how do we start reconciling a lot of those systems, and the smaller utilities often don't have GIS staff that can help in doing that. And I guess the last piece that we recognize and is important here is that most of drinking water data are just in tables and not in maps. So we're trying to fill the gap of how do we crosswalk the geospatial data and that tabular data to understand who's getting water from where. And so when we embarked on this at EPIC about 6 months ago, we started talking to the dozens of folks that have already started looking into this. And that is academics from Vanderbilt and UCLA, to tribes, to federal agencies across the government, as well as state regulators. And there are many consulting firms and technology companies. There's a lot of folks that are interested in this, have maybe started doing some data collation, or maybe would just really benefit from this and wanted to have a voice in the methodology and process that we were developing. Through this data collation process, we have been able to increase the data availability by about 70%. And in doing so, created kind of one unified data layer of all the existing service area boundaries where they were, and the approximated service area boundaries. And what I hope you hear above all from today's conversation, above all the technical details, is the value of sharing this data openly and accessibly and actively engaging with the plethora of stakeholders that could benefit from this information. And this is not perfect. This is the very first step towards trying to unify these data sets from approximating this. And we hope that this is the start of a very iterative and continuous process for data development. And that everybody on the audience probably has input on the methods, has maybe data that we didn't know about, or process notes that we can learn from and really hope to incorporate as we go forward. So yeah, just bear in mind, this was a quick sprint, and we're excited to imagine with y'all what we can accomplish going forward. And so with that, I'm going to hand it over to my colleague, Jess Goddard at SimpleLab to dive into the methodology.
Thanks, Jessie. Hi, everyone. I'm Jess Goddard. I'm the Chief Science Officer at SimpleLab, and we came to this with a slightly different motivation. We're a water quality data and testing company with clients from Fortune 500 companies to individuals at their homes. And we're really engaged at every level of making water quality testing and data faster and cheaper and more reliable. And on the note of reliability, this really brought us to this question of water service boundaries and what has been out there. And so it's been a pleasure to partner with EPIC and Internet of Water to really bring forward these methods. So what I'm going to talk about today is what we call a tiered explicit match and model approach for estimating nationwide water system boundaries. I have today with me here Ryan Shepard from SimpleLab, but this work has really been a product of our team with Rich Paolu from Water Data Lab and also Nora Brody at SimpleLab. So I'm presenting, but this is really a lot of teamwork, as you can already tell from the many collaborators. Walker, next slide, please. So I'm going to walk us through an outline of what this tiered approach looks like first, and then do a little bit of a deep dive. The first, we call it tiered because it's really a hierarchy. And the first tier of data for a given water system's boundary is a data set that already exists. So if the state has already provided, or if a state has already provided polygons or water service boundaries for a system, in this data layer, we assume that that is sort of the highest quality available information, and we retain that for the state. And that's the first tier. And in our case, we had about 12 states at the time where we could have easily accessible data, serving about 122 million people that are served by community water systems. Walker, next slide. The second tier of data are cases where we have some information about the water system, such as its name or a spatial point that represents the facility centroid. And in these cases, we try to estimate what the water service boundary is using available census polygons, which are referring to cities and towns and townships across the US. And we'll get into a little more detail about that. But that represents about 161 million people served by community water systems in this data layer. Next slide. And finally, for systems where we have a spatial point, but we actually have no match or reference to even an estimated census boundary, we decided to model a very simple spherical boundary around that point. So I'm going to go through these one by one and then kind of show how they come together at the end. So as I mentioned, there are 12 states that actually maintain and provide water service boundaries. And what I mean by that is that there's frequently a website where the state is actually hosting the data, and it can be easily retrieved and read by a machine. And for us, that has been a really important part of this project, to make something that is reproducible, transparent, and open access, so that as states and utilities improve their boundaries, that can be folded into this pipeline and this layer. So of course, we have a majority of states that are missing data, and there are potentially even more states with explicit boundaries that we may not have had access to. So that's just one thing to note, that we know of states that maintain boundaries, but they're not really available online. Next slide. And of course, there are some limitations to using the state boundary as sort of the gold standard here. It relies on the accuracy of the data from the state that developed it, and it's possible that there are boundaries that are used from approximations of other data sets that we're less aware of. The image that I'm showing here reflects water service boundaries in a zoomed in area in Missouri, and from what we know about water service boundaries, this looks like it could be a slight overbounding where we have polygons all matching up perfectly, covering areas that might actually be served by domestic wells or things like this. So I think, in general, more validation of state data is probably needed along the way, and Internet of Water will talk a little bit later about how we see this project incorporating such improvements moving forward. The second situation where we don't have an explicit boundary is our attempt to match information about each water system to a polygon that exists provided by the census. So as an example, what this image is showing is what we call the Tier 2A match, effectively a water system that has either a centroid, like in the city of Springfield on the left here with this little red dot. If that point is actually inside of a city boundary, such as the one represented here by Springfield, we would call that a spatial match. And what we would do is then assign that city boundary to the water system as an approximate representation for the service area boundary. In some cases, centroids might not be exactly where the city boundary is. There's a variety of reasons for that. And in these cases, we can do a name match. So you can see here that City of Springfield would match to Springfield in our algorithm. So this is a case of one water system matches to one census area, census place. And we see this as like a first approximation for what the service boundary could be. Walker, next slide. There are cases in this current layer where we actually have two systems or more matching to the same census place. So following the parallel from the previous slide, spatially, we might have points from two different systems that match to the same city boundary, or two names such as Springfield Water Authority and City of Springfield that match to the city. And this is we kind of, in our tiered system, we call this 2B because really two systems matching to the same census place is like a less accurate representation. But in the current matching algorithm, this is kind of one of the outputs of this approach. And research and data validation efforts on our end and also elsewhere have actually shown that this is a pretty good approximation for service areas. And in our case, we looked at, for the 12 states that actually have service area boundaries explicitly, what is the overlap between those explicit boundaries and census places that they get matched to. And we found that 84% of those tier 1 water system boundaries intersect with their matched census place boundary. So that gives us some confidence in the ability of this approach as an approximation, especially in the tier 2A case. But of course, going from tier 2A to tier 2B, we have less confidence about those systems where we have multiple systems with an overlapping boundary. Walker, next slide. So we're actually currently working on disaggregating the tier 2B systems into either tier 2A or tier 3, because it's a limitation that applying the same boundary to multiple systems, we know that that's inaccurate. So the representation of this image here shows a city boundary. And when you click on it, you can see there's 3 water systems associated with it. And another potential limitation, some work from Patterson et al. 2021 showed that some census areas might be better representations of water systems than others based on the water system type. So more quality assessment and quality control is really required at this level of the data set. And finally, so for cases where we had no matches to census places and we don't have any other information except for the location of a facility or a centroid, in other words, there's no tier 1 data, no tier 2 data, we used a modeling approach to estimate the boundary. There's a strong linear relationship between the number of service connections in a water system and the system's radius using a convex hull of the system. And that's present in the 12 states for which we have data. And so we used the states where we had data to basically develop a simple model to get a spherical boundary for systems. And we explored multiple modeling approaches, but ultimately the strong linear relationship between service connections and the service area boundary, as well as kind of the low data richness of the modeling environment, led us to use the more simple linear approach. Next slide, Walker. So as with all models, they're all wrong, but some are useful. And in this model, really the predictive power at the tails of the radii is somewhat less. So we end up having, very small systems and very large systems tend to be over and under predicted respectively in terms of when we look at how does the model perform if we look at states that actually have surface area boundaries in the first place. But another way that we can think about the utility of the model is really to demonstrate areas where we're just missing good quality data, and this is like an area for additional data collection. So the image I'm showing here is an example of the fact that about half the systems in the tier 3 quality have really poor data quality for the centroid. These are systems where they'll say, hey, the location of the system is based in the county centroid. We know that's not true. So this is an extreme case that we're showing. We've been calling it the pancake problem, where a ton of systems are all located at the county centroid, and then their modeled boundary is just stacked on top of one another. So really, within the tier 3 category, improving centroid quality is really important. But probably the best option here is to actually get more tier 1 data where we can, or start to kind of push the boundary forward a little bit in terms of data collection for that. Walker, next slide. So in sum, for every single water system, we ask this question: is there a tier 1 explicit boundary available? Is there a high quality match with a census place? Is there a centroid available where we can use a model? And in the end, we build out this full map combining these 3 tiers, where each water system is really labeled with our understanding of the confidence based on what tier it's in. So higher, the tier 1 is going to be the most confidence that we have, and tier 3 is the least confidence. And when I say confidence, what I'm really indicating here is our ability to say, we think this is a good representation of where the water system serves. Next slide. So in sum about the methods, we, as this is the kind of compilation of this across all the community water systems that we had data for, created the first unified national data set using these different tiers. And what this really leads us to is a provisional map that federal, state, and local partners and businesses can use and improve upon. And we have created a Github repository where all of the methods, data collection, ingestion, and assumptions are well documented. We encourage people who have the technical interest to join in and fork the repository and provide feedback. And of course, this will be an area of ongoing updates and support. So please definitely follow us there. Thanks, Jessie.
All right, so I'm going to take the handoff for a bit here. My name is Kyle Onda, and I'm the Associate Director of the Internet of Water project at the Center for Geospatial Solutions. We're part of the Internet of Water Coalition, which is a multi-organization kind of effort that's focused on improving the findability, accessibility, and interoperability of water data, very broadly construed, in a source to tap step from stream gauges to, to drinking water, quantity, quality, and use. And we've been involved in this project with EPIC in terms of advising on how to best publish the data so that it is findable and accessible and can be commented on and improved, and also helping think about where we go from here now that we have this initial first push from EPIC and SimpleLab. So the first thing that we want to do, right, is increase that tier 1 data. So we recognize that many utilities don't actually have the capacity to make, or they don't have digital surface area boundaries at all. So we're creating tools to create and update that boundary data to ensure that this data is available online and can be accessed by data aggregation activities like this. So next slide. And the other thing to think about, right, is this was just a first push, but utilities change, they shrink sometimes, they grow, they merge. And this first cut of data might not be accurate, even in the case of tier 1 boundaries. So we need these things to be able to be verified and updated regularly by water system personnel and validated by state regulators. So we at the Internet of Water Coalition are developing a tool to allow a regional or state or a national body, if interested, to manage the creation and updating of these layers. There will be a map-based interface to allow the drawing of a boundary from scratch or the modification of an existing boundary. And it's designed so that people with little to no GIS experience can submit boundaries. And we'll be running a version of this software ourselves and also making all the code open source so that state agencies, for example, can use it and modify it as they see fit. Next slide. So, which dovetails into my next point. State regulators, we've seen there's 12 states, 13, 14 with Utah and Arkansas that do publish these boundaries or have some program for aggregating and publishing them. Many other states might have this data, but may have not yet made it publicly available. We'd love to engage with these agencies to see if they'd be willing to share that data. Others may need funding and technical support to create these programs from scratch if they don't collect this data already. Next. And finally, overarching all of this, we believe the federal government has a role in funding and facilitating water system boundary development, establishing policies that ensure these boundaries are maintained. This sort of information seems like it would be a natural fit for something like the Safe Drinking Water Information System, and has obvious applications for things like Justice 40. So we believe the federal agencies should have an interest in this. And with that, I'll hand it back to Jessie.
Awesome. Thanks. So just in terms of where EPIC goes from here and where this group goes is we're going to have many additional workshops and briefings with folks about the use of this data and the ways we can improve it. If you're interested in continued conversation or collaboration, don't hesitate to get in touch. We are also going to be supporting a lot of different case studies about where and how this data can be used. What does it look like at the national level? How has a state used this and developed it? What does this mean for just a general resident? Like, why does this matter to someone of the general public? So we just want to publish a lot of those different types of case studies to show and demonstrate the value of this information in different contexts. And then lastly, as Kyle was mentioning there at the end, there's a set of policy solutions here as well that can improve and ensure the long-term ownership of this data set. EPIC does not have a vested interest in owning this or maintaining it or being the central person in any way, shape, or form, and really thinking about what is the larger coalition of folks and also who is the right holder in the end, whether that's EPA or other agencies, for this to be incorporated in broader data stewardship and management. So with that, I think we're right on time for any questions or discussion that folks have. I saw a number come through the chat, so we can start answering some of those. But with that, Walker, you can go ahead to the last slide just to turn it over to discussion. Walker did put something in the chat. We know that this was a lot of information to process at once. So if you have additional questions or thoughts that come to you after this particular presentation, don't hesitate to reach out there, either via email or through the form. So I can start with a couple of questions. It seems like some were answered already. I don't know, Jess or Peter, if y'all want to respond to these live or if you're going to keep typing. Either way works. I just don't know if everyone has the Q&A up.
Sure, I can at least take the first one. I haven't read the second one up. We've been answering questions in the Q&A. So there's a question about running the code where the SIDWIS data calls are failing. And then a second question about why SIDWIS data was not limited to active community water systems. So the first question is if there's something that's in erroring out that's on the code side that's worth posting on GitHub and asking a question about. If there's a failure on the side of the URL in terms of like calling, sometimes that happens. I've had a couple of actually really good experiences with the SIDWIS IT team. Anytime I've run into like basically error codes from the API. So if it's a persistent problem that's happening on their end, they're usually really responsive. So just thought I'd flag that. It could be from either side, but I'm not sure offhand which side that problem is coming from. The second question is, why was the SIDWIS data not limited to active community water systems? It actually is. We do filter the SIDWIS data set in the pipeline. We just call the entire data set at once in the download step. So hopefully that answers your question. I answered live and then pressed that button. Let's see if that works. If someone else has read the second question and wants to jump in, please go for it. Otherwise, I can read it out loud and answer on the fly.
I think that this would probably be a better question for Kyle or Peter. It's specifically about North Carolina. Maybe Kyle, if you have a thought, or as I read it further, it might be a question about how we associated different things.
Yeah, there might be a couple of things going on here. There was a project at Duke University where students created these boundaries, and it's possible that was just inaccurate. It also might just be that this is a case of 2B boundaries that Jess talked about, which is just the nature of the beast and the methods that were done so far. And so, of course, that's why we acknowledge this always needs to be improved. I think I can take from the second question also that what is the best way to suggest edits to the boundaries? One way is that GitHub repository, just submit an issue there. And
for the less technical folks among us, like I've not, maybe not submitting an issue to the GitHub repository. If you feel comfortable doing that, that is definitely a route. And then I think we've had several requests via email, so feel free to reach out to either myself or Walker via email, and we can get that incorporated into the data set. And then I think the last thing that maybe Kyle or Peter could speak to is hopefully in the fall, I think around September or October, maybe not want to hold you to a month, we will have this boundary updating tool, which will make it really easy for utilities themselves to just update that and have it incorporated. So I think it depends on like what level of boundary edits you're trying to make. And there's different approaches therein. There's a question about critical infrastructure concerns with this data. And I know, Peter, you have been thinking about that issue for a while, so maybe I'll pass that question to you.
Yeah. So critical infrastructure, it's a big question. Privacy and security is always a major question whenever we talk about data transparency. The key to this really is that when you modernize your data, privacy and security improve. And what the challenge we have today, the reason we cannot find all of these public water system boundaries is because they're held in non-modern systems. So the goal is to improve the modernization in such a way that privacy and security are also improved. In general, for the Internet of Water, it's a point of principle that we only publish data that has already been published, right? So the data producer controls whether or not the data are published and made available. So it's incumbent on the owners of critical infrastructure data to manage that data securely and to not, publish it if it shouldn't be published. Our systems only collect, that which is made public. We can also help design systems that are for authorized users, again, in the interest of modernizing and improving data privacy and security. So they're kind of intimately twined. We want modernization because that improves transparency, and it also improves those privacy and security questions.
And maybe since the only thing that I would add to this is we are just looking at the boundary of who is served. We are not through this project, nor do we intend to get the actual pipe location. So it's just who is that larger footprint of who you serve. So in that vein, we have not seen any critical infrastructure concerns associated with it. The next question is, can you further explain how water service area boundaries hope to be used by the various parties, the public, utilities, state, and federal agencies? This is exactly what we hope to cover in our case study series throughout the course of the summer and into the fall, but I can start to answer that a little bit and others feel free to chime in. So the first, in terms of the general public, I can say that if you ask most people who they get their water from, especially renters, they're not going to know the answer to that question. And it starts to become interesting when you have maybe kids going to daycare in one location, or your parents live somewhere else, and you just want to be able to know, is my water safe to drink or not? And how do I very easily know who I get water from if you're not directly paying the water bill? So that's one example that we think about for the general public. The second, with utilities, there's been a couple of examples of maybe wanting to merge with a neighboring water utility. If you we saw someone that had a chemical spill of some kind and needed to alert the downstream water utilities and their customers, and didn't have an easy way of doing so. The second, in terms of state and federal agencies, the biggest thing that we've heard at the state level, and the impetus for some of the boundaries being developed to date, was water use planning and drought and climate resilience, really. And so being able to understand how many people live within my service area relative to our drinking water supply is really important and critical for having that geospatial link and understanding the population served by federal agencies. Again, our initial impetus was for the Justice 40 initiative and understanding how we can better target resources to communities that have lack of access to safe, reliable, and affordable drinking water. And being able to characterize those communities is really hard and nearly impossible right now, because the data about water systems is just in a big table. It's not linked to any socio-demographic information. And so that was one of the primary drivers, I think, at the federal level from our perspective. That was it in a nutshell. I'm curious if Peter, Jess, Kyle have other examples. Yeah, go ahead, Jess.
Yeah, I thought I would maybe just provide a little bit of like the SimpleLab and more business side use case, which is that we just see a ton of demand at a grassroots level for people wanting to understand what's in their water quality. And on the same side, businesses and organizations working in local areas wanting to understand the local water quality so they can communicate with customers and constituents. And so in both of those contexts, connecting water quality data to service area boundaries is critical. And we have a lot of great data from CIDWIS and state level that demonstrates not just violations, but the general kind of characteristics of drinking water quality. But how do you then understand like who's exposed to those? And so I think there's just a lot of demand from businesses to individuals in their homes wanting to understand their exposures and potential risks that also drive the value of this. In addition to the broader federal state EJ cases as well, which is pretty interesting to see all those needs kind of coming together.
Yeah, I appreciate the sentiments in the chat. I'm really glad to hear that this is resonating with folks. The next question says that the state of Michigan has a government or maybe governor directive to build such a data set. Is it okay to use this data for that purpose and potentially add non-community water supply boundaries to that? I would say yes, please. This is hopefully kickstarting that process such that folks like have a baseline to begin with, and then we know that we have to improve from there. So just recognizing like when we think about the uses of this data, the tier 1 and tier 2A, we feel pretty good about. Tier 2B and tier 3 is where we know we need to improve. So if we're thinking about how a state can use this to kickstart that process, you start focusing on those particular areas, and we're more than happy to talk with states themselves as they're interested in developing this further. And adding non-community water supply boundaries to that as well. I don't know if others have specific thoughts on that regard, but I think, that we started with just community water systems, but would hope that we would be able to answer this question for all water systems.
Yeah, Jessie, that just reminded me too of the fact that we're adding a version to each of these outputs. So we're really thinking about the layer as a version, and this is like 1.00. So it's a 0.00. So it's important to remember that like we will be trying to work on all the limitations that we've put forward so that future versions are improved and can better meet these cases, which have pretty serious implications for how high the quality of the data is, et cetera.
Yeah, that's right. The next question says, you mentioned Justice 40 as a consideration or motivator for this tool. Are you planning to incorporate climate or demographic information? Have you investigated connections cross-use with EJ Screen or CGES from EPA and CEQ respectively? So you will see in the national case study that we will publish in the next few weeks, we are going to start doing that crosswalk between Right now, I think it's just demographic information. Climate could be something that someone could dive more into. And we are in active conversations with folks about how this can be used in the climate and economic justice screening tool. We've not yet broached the EJ screen question, but I think there's applications definitely relevant there. And I think it's just a matter of how much do we want to improve the quality of that before it's ready at a national scale to start being used in decision-making. And I don't think we're there yet, but hopefully in the next month or two, well, that's ambitious. And like over the next 6 months and year, we'll be really working on that so that it could be an effective tool in those, or effective data set in both of those tools. I see Peter, if you want to answer that further.
Yeah, I just wanted to add in about the climate data. It's a really cool idea. The challenge is when you say climate data, what do you mean? Like, so you really have to pick a particular climate use case. Flooding, drought, fire, like there's lots of different ways you can look at the climate problem. So really what we want to do is get this basic tool going and then, as Jess described, move in the direction of cross-cutting it with these other things. But yes, all those things are potentially possible.
Yeah. I see, Kyle, you queued yourself up to answer the following question about consumer confidence reports and water quality data. So go for it.
Yeah, so I'll provide a link in the chat. If you look at the web map that the Internet of Water published, which is based on this data product, we actually did put a link into at least the CIDWIS, that basic CIDWIS query page. CCRs could be coming down the pipe. This is sort of related to the previous question too. I think the idea is this is a base data product that includes the minimum information necessary to know where a boundary is for a given utility. And then from there, any number of value-added data products can be produced. So we at the Internet of Water will probably be producing many such things, and it will go into our larger information architecture that links all kinds of different water data together. And so look out for that, or feel free to make it yourself.
And then the next question is, are there any federal partners that we are presently engaged with in any capacity for this project? Several dozens, a number of them are on this call today, which I'm really excited about. But I would say mostly we've been talking with folks at EPA from the Office of Drinking Water and Groundwater, the state revolving funds folks, the Office of Policy. Yeah, there's a number of other agencies that we could rattle off. We've been talking with Indian Health Services, Council on Environmental Quality, HHS. So there's many different agencies that are interested in and could benefit from this data. And I would say the federal agency is large. So if there's other folks or folks that are on the call that we've not talked with yet, more than happy to be in touch and start unifying those conversations. And again, we hope that again, EPIC doesn't need to hold these relationships. This is a broader community of folks and coalition that is interested in this and could help in improving the data down the line or maintaining it. What federal agencies do we think should maintain this data over time? That's a question back to folks on this call. We see a natural connection with the Safe Drinking Water Information System that's managed with the EPA. So that's one of the ones that we're currently engaging with and thinking about. But again, that's probably like a year or two out from actually being maintained and owned by that group if that is the route that's ended up going. But we've also seen folks at other agencies that could benefit from this data, especially with respect to water use, drought planning, climate resilience, and I think, again, the Council on Environmental Quality with respect to the climate and economic justice screening tool, but I don't think they would maintain that data. They'd be a benefactor or beneficiary of the data. So kind of just separating those two pieces. But in the chat, if anyone thinks there's other agencies that should maintain this, more than happy to chat about that. Any other questions or thoughts that are coming up? Oh, another question. How much of the tier 1 data actually have more refined boundaries than the tier 2A data? Jess or Ryan, you want to take that?
I'm curious if the question is asking about whether or not like the census place data is in any way like inferior to tier 1A. I'm not totally sure I understand the question. If that in some ways the difference would be that a water system or a utility is specifically mapping out their boundaries based on their known addresses, whereas the city boundary would be extent. But Walker, I feel like you probably have more to add there.
Yeah, I can at least try to answer this one. So I think, yeah, my interpretation of the question is, right, so the tier 2A data is specifically, we're only using census place boundaries and then assigning water systems to those boundaries. But the tier 1 data, there's the possibility that when the state, like Texas, for example, when they created their data set, there are definitely systems where that is the assignment process that they use, that they decided to use, like this is an example, I'm not saying yes for sure, but the boundary of Houston could be the boundary of that water system. But there's definitely many water systems that either someone at a state agency or a water system manager themselves drew that boundary, and then, either based on the locations of their pipes, based on, as Jess was saying, the locations of all the addresses that they serve, they draw that boundary, and then depending on if they have a GIS office or not, find a way to digitize that boundary and get it into sort of a geospatial environment from maybe a PDF or a JPEG or something like that. So there's I think that there is definitely tier 1 data is sort of the most reliable, but sometimes it is the same as that tier 2A data.
Yeah, I think maybe given the question that just came through the chat as well about an estimate of drawn boundaries versus census place by state, would it be helpful to show that slide again that showed the breakdown of like the number of water systems in each of the categories? And maybe that would help orient folks, like the breakdown between each of those different pieces. I think that's what they meant by drawn versus census place boundaries.
They might also be just asking, like, is it possible to tell which state did that? I think currently in this data set, no, but certain states do provide that metadata in their version, and we can think about a way to standardize that metadata and fold it into this product. I think that should be a priority because that's an important question.
Yeah, and I think that's a great point, Kyle, that came up in the number of interviews that we did throughout the course of this conversation or throughout the course of this project. There were several times where we would hear qualitatively, oh, we know this state's data is actually not that great. It was done in this particular way, and we really need to improve in that respect. So there's probably qualitative assessments that we can do to also to accompany the quantitative data. But this is just the breakdown of, again, the number of systems in each of those tiers and the population that they served. I see there's another question about, is anyone on your team or in your networks using the systems boundaries to identify the communities not served by community water systems? I saw Jess, you want to come off mute if you want to answer that question.
Yeah, I think this is definitely something that SimpleLab is planning and considering in light of having been developing out the system boundaries. So we don't have a timeline on that, but it's definitely in our sights.
Yeah, and I think that's one of the thorny issues that we ran into in this project was especially related to Indian country, where a community water system says that they might serve this particular area. You talk to the tribes to say, no, we do not get water from them. So how do we start understanding those exclusions in the data and more accurately represent who gets water from where? So I do think that that's a really important area that we're focused on, and as we improve this data. And then the other piece is, right, how many are being served by wells, or how many, what is that larger distribution of who gets water from where, I think, which is the overarching question that we hope to be able, as a North Star, at least. The next question was, I joined a bit late, but did you compare tier 1 water system boundaries with tier 2 estimations? How well did tier 2 do in those cases? And we did speak to that. So I don't know, Jess or Ryan, if you want to answer that.
Yeah, I can just do a quick recap. We intersected the areas of the tier 1 data with the tier 2 estimates and found that they intersected 84% of the time. And then let me just get the number in front of me. In cases where they did not actually match or were where like the tier 2 and the tier 1 were not intersecting, which is about 16%, the median distance between the matched tier 1 and tier 2 geometries was about 9 miles. and the interquartile range of that was about 5 to 25 miles. So the reason why I bring that up is because it kind of indicates that even in cases, even that 16% where they're not matching, we're seeing a very close locational approximation. And there's probably other ways to explore and validate kind of that approach of how well the actual shape relates to the tier 1 data, which speaks a little to that prior question too about like how different are the actual boundaries. But we haven't done an in-depth investigation of like how different the shapes are.
And Kyle, go ahead.
I'll point out that the reference report earlier, I don't know if you can put in the chat, Jesse, from Patterson et al. 2021, directly addressed this question, did a number of statistical analyses, and actually sort of looked at what difference does it make when you're calculating demographics based on municipal boundaries versus drawn boundaries. The answer there was basically, it's really good for a local government-owned system for the most part, and pretty bad for investor-owned utilities and these sort of district authorities that are often parts of cities or multiple cities. And that's something to suss out, and buyer beware.
Yeah, I saw Joe Shapiro raised his hand. I'm not sure in the webinar format if you're able to come off mute. Or Lena, maybe our tech support can help me figure that out. Or Joe, feel free to type. Oh, question's been answered. Great. Okay.
It looks like I'm the one who can take people off mute, so I'll be more on top of that.
Thanks. Thanks. Yeah, any other questions? This is all great.
I would love to hear more from the audience for people who are listening. If there are use cases that we've discussed, if there are any that are out there that we haven't talked about that you're really concerned about or are thinking about. I know someone brought up a point regarding the use case of thinking about bringing people from domestic wells or who are outside the bounds into the bounds of systems as an interesting use case scenario. So just want to prompt everyone in case there's something else out there that we haven't thought about on today's call. No pressure though.
As everyone is thinking, Adam, I muted myself while trying to unmute you. Okay, Adam, it looks like you're allowed to talk, so you should be able to unmute yourself.
Okay, can people hear me?
Yes.
Okay. Just something that when we were talking with these folks regarding Utah, just something that we've run into that's just something to maybe just keep aware of is that we've run into issues where cities or municipalities didn't necessarily want to show their entire service area because it included some properties outside of their municipal boundary. And they basically didn't want people outside of their municipal boundary requesting water service from the city outside because they were basically grandfathered in, right? Properties that were grandfathered in, but are not actually technically within the city. So we've had issues like that where they didn't necessarily want to show service outside of their city boundary. So at any rate, that's just an interesting maybe limitation or concern that some of these systems might have.
Thanks for providing that extra context, Adam. Another maybe thing to guide people's thinking or any further things to add would be, data sources that we have missed. I know people were pretty quick to chime in the chat that Utah has really good data that hasn't yet been incorporated into the map. And Kyle also mentioned that Arkansas has service area boundary data that we'll be incorporating shortly as well. But even apart from other state data sets, maybe other sources that we could be using to try to address the pancake problem that Jess brought up, where we have 80 systems on top of each other because they all claim, well, because the data sources we have say that all of them have their centroid at the center of that county, which we know is not true. So thinking about other sorts of data sets that we might look at to improve our estimations.
Just to go back to a question someone asked a while ago that we've kind of moved on from, but wanted to expand on a bit. This person brought up an area, I think it was in North Carolina, that they found a couple of matches that were incorrect. And I will just say that that tier 2 area is definitely one of the main areas of refinement for us, that trying to match there are these data sets where we know which utility IDs they're referring to, and then there's data sets where we don't know what the utility ID is. So we have the SIDWIS on one side where we know the utility ID, and then on the other side we have like a Tiger Place, which no one has matched these Tiger Places to the exact utility ID. And so it's a bit of an art trying to make sure we've narrowed in on the right Tiger Place, and not capturing too many incorrect matches. We do end up with those cases where 2 utilities end up pointing to the same Tiger Place, and we know that those aren't going to be identical boundaries. But trying to refine that and sort apart which is the best match and things like that are definitely one of the next places we're going to be focusing.
Awesome. Well, I think the questions have died down a bit. I hope.
I think we've got one more. Yep.
Sorry. Will there be historic versions of the data in the events that boundaries change and there may be a need to keep historic boundary for issues with contamination, what the source is, et cetera? There will be. So that's what we talked about earlier with version control and being able to see those updates over time. I don't know how much we'll want to go back in history, but we do intend to have some kind of tracker on our website or in the GitHub repository or in some other location where you can see how many systems have moved from tier 2A to tier 1. How much are we improving the accuracy or confidence in those boundaries over time, which would come from that version control and history. So yeah, we intend to make all of that available. And right now that's hosted on HydroShare. That's likely the location that it will be on for the foreseeable future.
And to add a little bit to that, so that sort of version control and looking at updates to the system boundaries in the short term, yeah, that will apply to as we improve our methods and get more raw data. In the future, that will also apply to when a system actually expands. They already have an accurate boundary, then they expand or they merge with another system and update their boundary, and that will sort of be able to see the version of those updates as well, as I think Kyle referenced in particular with the About Us tool that Internet of Water is working on.
Yeah. Well, I think with that, if there's no other questions in the chat, again, Walker did put a form there. My email is attached to this presentation. I can put that in the chat for anyone that has additional questions or wants to engage. Just really appreciate y'all's time today. The number of folks that we do know and have not yet met. So thank you again. We'll be working on this for many, many months to come. And just hope this is the first of many conversations. So thank you all.